Hi, everybody. Welcome to the Microsoft Partner Showcase. I'm Brian Hitney, Solution Architect at Microsoft, focused on data and analytics. And today I'm delighted to have Patrick and Mike from Lightbeam Health here to talk about their solution and a little bit about the healthcare industry and total patient care and how AI and analytics is shaping the healthcare industry. So let's just start by introducing or having you two introduce yourselves and your role at Lightbeam. Mike, do you want to start with a little bit about yourself and your role?
Sure. I'm Mike Hoekstra. I'm the Chief Technology Officer here at Lightbeam, heavily focused on kind of data analytics and infrastructure, working with companies like Microsoft to make sure that we're staying up to date and kind of on the cutting edge of what's available to us technology-wise. Patrick?
Thanks, Mike. Patrick Burton, Senior Vice President of Business Development, oversee all of our partnerships, including our great relationship with our friends at Microsoft.
Great. All right. Well, thanks very much. I appreciate the intros. And I think what we'll do, we'll start off talking a little bit about Lightbeam, the types of solutions that you have. And then, Mike, you could dive into a little bit more of the architecture and some of the technical pieces behind the scenes. And then we'll wrap up with next steps where people can go to learn more. So let's get started.
Thank you, Brian. Really appreciate the opportunity to share a little bit about who Lightbeam is and what we do and how we do it a little bit differently to help improve healthcare. For nearly 12 years, Lightbeam's been solely and entirely dedicated to helping healthcare organizations advance their participation and improve their performance within value-based care. While we're very proud of our accomplishments and accolades, we're most grateful for our client partnerships and immensely proud of the results that we've helped them achieve over our 12 years. So why are we here? In short, the current healthcare system is not financially sustainable. Healthcare reimbursement is declining versus the rate of costs increasing. We've never seen a worse labor crisis, and more requirements are piling on to professionals who are increasingly experiencing burnout. Many organizations are looking toward value-based reimbursement as the quote-unquote off-ramp from the current system, but traditional approaches to managing value-based patient populations leave a lot to be desired. Most solutions in our space simply produce lists of patients that require a significant amount of quote-unquote below-license manual effort to activate and drive improved performance. And given the labor crunch, this capacity bottleneck limits success and does not offer a sustainable approach to scale these programs to cover entire populations. At Lightbeam, we firmly believe that the way out of the fee-for-service grind is through proactive management of entire populations under value-based reimbursement models. The management of entire risk-based populations serves as the bargaining chip for health plans and providers to align around incentives and reimbursement to the benefit of all parties, including the plan, the providers, and most importantly, the patients. At our core, Lightbeam is a SaaS platform on Azure that leverages data to identify modifiable risk within patient populations and automate downstream workflows to proactively intervene with patients and drive improved outcomes. We have a long-standing track record that spans hundreds of value-based organizations, thousands of data interfaces, and billions of dollars avoided to our healthcare economy. We also offer staffing augmentation for care coordination, management, and even social support. While Lightbeam offers a SaaS-based platform, Lightbeam is not a technology-only vendor. Value-based care is evolving very rapidly, so it's important to stay strategically and operationally aligned with our client partners such that we can ensure that these changes influence future adjustments to configuration, additions to programs, and helping unlock even better outcomes. First, we complete deep dive discovery sessions with our client partners to inform optimal platform configuration right out of the gate. We then begin consuming and aggregating and validating all of the different data that we leverage in our analytics platform and also produce a measured baseline performance output. We then review that baseline performance with our client partner to help determine which programs will help drive the most impact to their organization and for their patients. And then we even help them develop and deploy the clinical and operational workflows that are necessary to enable and scale these programs. After a period of action by the client partner to intervene with patients, we measure and review the results on a regular cadence throughout the life of our partnership. So how do we do it? Lightbeam identifies blind spots within at-risk populations that, quite frankly, other solutions can't see nor identify. We start by aggregating and normalizing the core data sets that are common within our field. This includes clinical data from electronic health records, health information exchange data, and admission, discharge, and transfer information that we can source either from hospital systems and/or health information exchanges. On top of the clinical data, we layer in data from the payer, which includes attribution rosters, paid claims information, revenue, quality, and risk adjustment. On top of the core data, we layer in social vulnerability data that we acquire from public sources like Census Bureau, CDC, EPA, Housing and Urban Development, Department of Agriculture, NOAA, and more. And then we further supplement the social vulnerability data with third-party paid consumer data that we get at the individual patient level. Finally, we activate a real-time digital feedback loop to collect patient-reported outcomes between telephonic or in-person touchpoints, resulting in the most comprehensive and personalized profile for each individual patient. Once we know what makes each patient special and unique, we orchestrate the appropriate downstream workflows and track program outcomes. Some patients require intensive human-driven care management and coordination, while others would benefit from what we call deviceless remote patient monitoring. On the healthier end of the risk spectrum, patients might simply be engaged as they're routinely overdue for various preventive services and wellness visits. When we zoom out, we call this entire process of identifying patient-level risk and the downstream automation and coordination of people, process, and activities as care orchestration. At a high level, we break this down into buckets: stratification, or the identification and classification of risk; intervention, which pathway is most appropriate for each individual patient; the action itself to intervene with the patient; and then the measurement of outcomes through various lenses like quality, cost, utilization, and risk. Diving in very specifically, we'll talk about a patient-centric use case that really highlights the power of the combined platform and Lightbeam ecosystem. So once we gather all of the data on the left, we start seeing our population and can start making patient identification. Today, we're going to talk about Mr. Smith. Based on Mr. Smith's personalized clinical cost and social risk profile, Lightbeam automatically orchestrates the appropriate programs and interventions to meet Mr. Smith's individual needs. In his case, we use a combination of rules-based filtering and AI-driven social vulnerability modeling to identify Mr. Smith as a currently well-managed but rising or emerging risk COPD patient who has a high likelihood of transportation insecurity. Because 1 in 5 rising risk patients will escalate to the high-risk pool annually, we enroll Mr. Smith in a deviceless remote patient monitoring program for his COPD and social needs. As Mr. Smith responds to periodic ongoing prompts, Lightbeam re-stratifies him as requiring immediate intervention due to his breathing worsening. At that time, the appropriate resource or resources are provided discrete, actionable tasks to immediately engage Mr. Smith. As a result, and as is common every day with our clients, we help avoid a hospitalization, an emergency department visit, and potentially a poor patient outcome and reduced patient satisfaction. Now, zooming back out, for every 100,000 patients in your population, there are 20,000 rising risk patients, 20,000 Mr. Smiths. How do we even begin to tackle this scale? Traditional care management capacity states that approximately 140 to 150 high-risk patients can be managed per full-time care manager. However, with Lightbeam, using the combination of the time saved by automation and the extension of human care management with virtual engagement, we're able to break free of the status quo for capacity and increase care management coverage by over 5 to 10x without adding any additional operational overhead. Before we briefly recap, I want to share a story about one of our client partners, who is a large multi-hospital health system located in the Midwest. Over a 5-year measurement period, and by implementing just one portion of our overall platform, they were able to validate over $53 million in avoided costs and expand their care management coverage by over 5x, meaning that each care manager who previously was able to manage a panel of 150 patients is now managing 800 patients post-implementation. As a result of their efforts in the most recently paid performance year within the CMMI Accountable Care Organization program, or ACO program alone, they received an earned savings check of over $61 million. In summary, Lightbeam offers scalable end-to-end value-based transformation that drives better results with fewer headaches. From data aggregation to performance baselining, patient stratification, automation of workflows, streamlined actions, and measuring outcomes, Lightbeam enables our client partners to execute on their own unique pathway to value-based care. With that, I'll turn it over to Mike Hochster, who will walk through a bit of the technical aspects of Lightbeam.
Thank you, Patrick. So to go through a little bit of what the architecture looks like, we'll go through a little bit of what we have to do with the data that we receive. So to start with, data ingestion. We receive a lot of data from our clients from a lot of different sources, and healthcare data can be messy. So we start by kind of staging everything and doing a great deal of data normalization and cleaning and deduplication to be able to pass on to the main portion of our application as clean of data as we possibly can. So our enterprise data warehouse then takes all of that information and runs through kind of a second pass series of calculations and logic that we run on that to eventually surface into tables the insights that Patrick was just talking about, the different models for machine learning, the different suite of analytics, all the different ways that we look at that data to ensure that we can make informed decisions and that our clients can get the most value out of that. So we started this 11 years ago the way that a lot of people started this 11 years ago, which is we went to a data center and we had our own cage in a data center. We bought a bunch of hardware and we built a bunch of servers. And as we grew, this became a lot of work. And so we started in 2019 activities to essentially lift and shift these workloads into Azure. So our initial take on that was to take the virtual machines that we were managing within our data center on our hardware and kind of replicate those virtual machines and lift them into Azure and have them do essentially the same thing that we were doing within our data center. So that was kind of our initial move into Azure, was very similar to the infrastructure that we had, but let Azure manage the entire hardware piece of it. So we were successful in doing that, and then shortly after that, kind of quickly realized the value of some of the managed services for things where we had built some of these ourselves. So at a high level, our application is very, very data heavy. We load a bunch of data. There's a lot of compute. What we were doing as far as that goes is we had virtual machine SQL servers that we were managing, and they were provisioned to be able to handle the data processing workloads that we were throwing at these databases. So very large databases with a lot of compute. And because there were virtual machines, what we kind of found was that there was a lot of wasted compute. We had these provisioned virtual machines that were very large that were largely idle when we weren't processing data. And so that was one of the very attractive kind of pieces about looking at the hyperscale tier of the Azure SQL database. So we started to investigate and have been migrating our clients from virtual machine SQL Server databases to Azure SQL hyperscale databases. And that's allowed us an enormous amount of flexibility when it comes to provisioning and storage. We never have to take a server offline to add more disk, as well as scalability really as needed depending on the workload that we're running. We can run at one level for kind of your normal user workload. We can automatically scale to a completely different level for an ETL or data processing type of workload, which allows us to shift as needed to meet the demands of the workload that we're trying to run on these databases. In addition to some big improvements in the data processing architecture and infrastructure, we've also taken advantage of multiple cloud solutions such as Azure DevOps to ensure that we have builds being run through kind of a very industry standard and kind of Microsoft approved best practice, checking our builds against test environments and dev environments and doing very adequate testing to ensure that our application is very consistent and stable, as well as using Azure Data Factory as the main mechanism to orchestrate our ETL jobs. So going through in Data Factory when it's data processing time, initiating a job to take the database that we're looking at, scale it to an appropriate level for their particular size, for their particular workload that we're about to run, running through that workload, and then kind of putting it back to normal to ensure that we don't have very over-provisioned databases eating up cost where we don't need them to. So it's really allowed us to optimize our workloads.
So when you talk about scaling then to meet the demand, particularly during ETL jobs that might require a lot of processing, is that something that typically happens once a day or perhaps many times a day? As it can depend on the client?
There's a lot of settings and options that we have. There are different kind of pieces of data that have different requirements. So some of that data is real time. So certain data such as admit, discharge, transfer pings, ADT data, we receive the data on a real time basis when a patient shows up at the hospital. So that data will be processed in almost real time so that we can alert the care manager or the folks on the care orchestration team that an event has just happened. There's other workloads which are a little bit more nightly, weekly, monthly, such as batch claim loads, where a payer has provided a large amount of batch claims data, and so those batch operations can run on a different schedule overnight or over the weekend at a different scale level.
I could see that as being a tremendous advantage for your customers, right? Because you don't have to worry about performance concerns or issues, or how much headroom do we have on the server that you're trying to manage. Things can scale based off of rules or data or anything else that you have in place. So I think that can offer a huge number of advantages for how this is consumed by your customers.
Yeah, I completely agree. So every one of our client environments has its own Azure SQL database that is scaled appropriately to that particular client environment. We did have that noisy neighbor problem when we were running virtual machine SQL servers. It's not feasible for us to have a SQL server per customer, so we would have databases on shared servers. Usually that's fine, but then you have that kind of batch problem where one of them uploads a very, very large load of claims data. If many of them do that on the same day, then yeah, you run into the limit of having multiple customers on a shared set of compute and storage. So with every client being very independent now, nobody can step on anybody's toes when it comes to data processing or storage or any one of these, as well as some of the testing things that we talked about. We want to make copies of environments and test new code against them. The database copy infrastructure that exists on the hyperscale allows you to make copies of very large databases very quickly. So that's now a fully automated process where it used to be something that a DBA would need to schedule and do.
Yeah, I imagine it probably simplifies, and hopefully it's not something you've needed to test, but I'm sure it simplifies the disaster recovery planning and all of those you must be prepared for. Hopefully you never need it, but nevertheless, those kinds of situations will come up from time to time, and to have the infrastructure there to manage most of that for you, hopefully, right? You hopefully never have to test it, but the functionality that's there to do some of that is very robust. So that hopefully saves a lot of time on your engineering side from having to have disaster recovery planning and procedures in place when a lot of that can be managed by, in this case, the Azure infrastructure for you.
Absolutely. Yeah, you can with virtual machines set up zone redundant active nodes of SQL servers. It is much more work than checking the box to have geo-redundant storage on a database. So
Right.
our ability to turn on geo-redundancy and have those features that Microsoft is really good at handling SQL Server and managing it. We'll just let Microsoft do that bit of the work. Getting in a little bit more to kind of the ETL and data exports here. Our clients consume this data in many different ways, depending on the client, depends on kind of how they want to. So having the ability to have enormous amount of flexibility with the cloud services such as Data Factory, like I mentioned, blob storage to make things available, as well as provide that through a web application, or another option that a lot of our clients have opted for is to receive this data in a reporting database, where we're using that same ETL infrastructure, using Azure SQL database, using Azure Data Factory to populate a reporting database where our clients can actually interact in almost a development environment on their own Azure SQL database, which is isolated and used purely for their reporting needs. So providing those as well using the cloud services has made the implementation of the spin up of the maintenance of much easier. So our CareSignal, and one of the key pieces of our care orchestration platform is the patient communication aspect of it, which runs through now some hosted kind of web services type of layers, which has also, just like you mentioned on the database, the ability to have an enormous amount of redundancy and kind of safety around those pieces. If we're interacting with thousands of patients on a daily basis, the importance of ensuring the uptime of that service it is paramount. We have to make sure that these patients, especially these medium to high risk patients, are that we're communicating with them so that we know what's going on, so that we can properly action the humans that are responding to those alerts. We can't afford for these things to go down. So running them on the Azure architecture allows us to have minimal redundancy in a kind of dev test environment, which of course then carries with it minimal cost, but then also have much of that kind of additional redundancy and geo redundancy that exists when we are in production and working at a production scale, and we have these sort of services where it's extremely important that they're always online. So using the Azure platform and working with the Microsoft partners to bounce ideas past and kind of see the way that this should be architected as we're approaching these problems has been huge for Lightbeam, and the ability to get feedback from experts and then implement that feedback within the Azure portal has brought us a long way. The Jvion AI, so AI is everywhere these days. We've been actually running machine learning and AI across these data sets for many years. And so this was kind of similar. We had this running on virtual machines on hardware that we owned. And moving that more to using the Azure stack of machine learning, data science, AI has certainly simplified the ability to scale as needed when we need to run these sort of very computationally heavy models where we're predicting a variety of outcomes for the patient population based on an enormous amount of training and scoring data. So because these are so extremely computation heavy, to maintain hardware just for the need to maybe run it next week, that's expensive. So with the Azure model using kind of a Kubernetes type of infrastructure, we have the ability to then, as needed, spin up the infrastructure that is required to run everything that we need to run, extract that data into where our clients are going to be consuming that data, and then have the hardware resource, which we historically would have paid for, just kind of go away, and we'll wake it back up and create it again next time. So the ability to do that at scale for, as our clients get larger, as our clients get more, has been extremely valuable for us to be able to provision as needed enormous amounts of compute, use it, have it go away, and kind of right size what we're using to meet the demand at the time.
So what are some of the best practices you've learned through all of this, and especially given the amount of data that you're bringing in that is sourced, say, perhaps from third party? What are some of the things that you've learned and some of the challenges you've had to overcome?
Sure. So probably validation would be the first one. You're going to run a lot of computation on a lot of data, and you definitely need to put it through its paces before you make these sort of things production. AI is great. It has the ability to make mistakes, and you need humans that are going to be able to know what is a mistake and what is not. So I'd say making sure that you put adequate validation into your process would be one of the most important kind of aspects of building things using this. The other thing that we have learned is that when you have a problem and you need to solve that problem, sometimes there's a dozen different ways that you can solve that problem using the different Azure tool stacks. There's a lot of ways to do those things, and there's slightly different pros and cons to each of them. So making sure that you look at all the available options and really choose the one that's best for your workload, both from a long-term scalability, ease of building, and then making sure that it's right size for your solution. I know we've had numerous conversations with our Microsoft account team where we have a problem, we're looking for a solution, and we're looking at all of these different potential ways to solve it, and they'll come with another one that wasn't even on our radar, which may or may not end up being the one that we go with, but there's a lot of ways to solve the problems, and finding the right one for that solution can be a challenge, but it's worth putting in the legwork and putting in the time up front to adequately plan the solution that you're going for, and make sure that you get the outcomes you're looking for doing that.
So why don't we talk about then next steps in getting started? How do people who want to learn more, where do they find you, and how do they get started?
Yeah, thanks, Brian. You can find us on the web at lightbeamhealth.com. You can also find us in the field at various industry events like HIMSS, AHIP, AMGA, and NACOS. You'll want to stay tuned because we're releasing some awesome functionality powered by Microsoft, including Lisa, or the Lightbeam Intelligence Support Agent, powered by ChatGPT-4, as well as Copilot for Cohorts, which enables even easier querying of patient populations using natural language and leveraging the Microsoft Copilot suite. Thanks again.
I'm looking forward to that. That sounds exciting. And perhaps in a future episode, we could dive more into some of the AI components. I'd love to do that. But in the meantime, thank you both, Patrick and Mike, for taking the time to join us and go through all of that information. It's a really exciting time in healthcare with all of the advances in analytics and AI. So thanks for taking that time again. I appreciate it. And thank you for tuning in and watching this Microsoft Partner Showcase. We'll see you next time. Take care, everybody.